Hello, hello.
Hey Eli.
Hey, can you hear me?
Hey.
Yeah, good and clear.
Great. Same. Can hear you guys. All right. Welcome, folks. There'll be some people rolling in as we get going, but today we're here for a Chainlink workshop. It's around VRF, which we'll get into a bit. We'll just start off probably with some intros. We have Todor and Eddie here. They'll just talk about what they do at Chainlink Labs. And then Eddie will give an introduction to VRF, how devs can use it. Todor will introduce some of the use cases in a little bit of a, deeper explanation. And he'll also explain some of the dev implementations. And that's pretty much what we have in store for you. So I imagine the audience will be of the developer nature today. So why don't we just kick it off? Maybe you guys just introduce yourselves, what you do, and then we can get into introducing what VRF exactly is. We start with you, Eddie.
Sure thing. Thanks, Eli. So first of all, welcome everyone to this to the session. We're very thankful. Thanks Arbitrum as well. So my name's Eddie, and then I am the product manager of Chainlink VRF, and Todor here is the go-to-market lead of VRF, which I'll pass the mic to Todor anyway here. Then so he can give a better introduction of himself, and then so in today's session we will cover. So why VRF? What is VRF, and how that can enable, I guess, developers for building amazing dApps? Toto, you might want to introduce yourself.
Yeah. Hey, everyone. I think if we have any developers from the audience here who have integrated Chainlink VRF before, they've probably talked to me. I've been taking care of looking after VRF for pretty much since it started, and yeah, that's pretty much most of what I do here at Chainlink Labs. Nice to meet you, everyone. Looking forward to this.
All right, great. Thanks for the intros, guys. And let's just get into it. What is VRF? Maybe simple, low-level explanation, and then maybe a higher-level one as well, if you can.
Yep, sure. Do you want us to now start, I guess, the slide sharing everything, or
yeah. If you'd like, you can go ahead and start presenting that as well.
Okay, sure. I think it would be better if we can come up with the flood slides. Let me just share my screen. Wait a second. Can you guys see my screen?
Yeah, I just pulled it up on this stage.
Okay, cool. All right. So again, thank you everyone for your time. Let me just give a little bit introduction about VRF right now. So VRF stands for Verifiable Randomness Function. So essentially a on-chain tamper-proof verifiable way of generating randomness for Web3 services. That's a one sentence explanation for it. But but to start, I guess I will say from randomness per se. So what is randomness? Randomness is apparent or actual lack of pattern or predictability in events. That's a wiki explanations. I like it as well. So it's essentially just saying it's a decision factor when you want a unpredictable event, right? You see this in a lot of real life use cases. Votes, ballots, raffles, gaming activities, a lot of things. And in Web2 world, it's pretty common. So if you have a pseudo randomness generated with an algorithm or some third-party services, centralized services that's hosting it, it's very common, very well adopted. However, this is actually a very big challenge in the Web3 space if you want it to be fair, though. The reason is that we all know that public ledger, blockchain is a public ledger that's pretty much opening everything on chain. So with a given algorithm, and then where an entropy is coming, people might be able to attack them through overseeing or predicting the ending result. So in the Web3 space, it's quite challenging actually. Let's go to the next slide. And this is why we want to have a better solution to address this issue. So in this solution, what we're expecting is, first of all, definitely unpredictability. So no one should know anything ahead of time. All participants should be in the dark when they're requesting this randomness. And then also the algorithm or the cryptographical perspective needs to be fair. So everything should be equally uncertain. So there's no lucky odds or favor odds can happen from this algorithm while we're generating randomness. And then this is Web3 space. So we want everything to be provable, verifiable. This is true. This is fair. Well, just because a lot of these Web3 services right now are serving in a decentralized way. The whole point of dApps is to be fair to the communities, to the users. So we want it to be verifiable. Anyone can check. There's a clear audit of trails. And lastly, it's a very common thing as well in all the Web3 service infrastructures is that it needs to be tamper-proof. So we will need to be resistant to all the manipulations. This is particularly important because Chainlink is known for providing a high standard security solutions to all these use cases. So we want the source to be not tamper impacted, and also as well as the output, it shouldn't be able to alter for manipulations. So with all these properties, we have decided to build Chainlink VRF. So this is a high level, I guess, explanation of the flow. User contract here is, well, the dApps. So whether it's a game, a blockchain game, or a NFT project. So for example, you're buying something on OpenSea, and then it gets reviewed after 2 days for the rarity you actually get. All these things are user contracts that will request randomness from VRF coordinator. So VRF coordinator is our developed solution, which is also our contract. And then we will receive this request, this randomness request, and then put it on chain in the transaction. And then VRF node will listen to all these requests in the transaction and then process the randomness generation and then responds back through VRF coordinator to user contract. You see the whole flow right now, it's provable because there is a transaction involved. So open transaction with a request and response. You will be able to check online through on-chain, either with smart contracts or verifiable contracts, or simply check it on the Block Explorer. And at the same time, you can see that the randomness generation only happens when VRF nodes listen to the request. So when you're requesting, all these user contract or dApp developers or end users, they won't be able to predict anything. They won't know how it's processed. But afterwards, they're always able to revisit the whole trail to prove that everything is fair and square. So yeah, this is the high level, I guess, flow of how VRF is processing. And then, yeah, these are the properties we're providing. We have been launched since October 2020. So it's already 2 years, 3 years almost. And then we are already live on 5 different chains now with Arbitrum. So we're really hoping that we can help developers on Arbitrum to also enable your success in building your amazing dApps. So with VRF solutions, it's tamper-proof. So no one, even Oracle staffs, anyone can alter or tamper the RNG process. We are already taking in considerations with all the octave vectors and nuances of each chain. And then it's unbiased. So definitely not possible to predict any randomness to increase their odds of success or favorable way. And then lastly, it's verifiable. So everything should be verifiable on contracts or on the Explorer. Everything's on chain, proof is there. And then you don't need to trust us. There's no trust inside. So it's a trustless and cryptographic way of getting randomness using VRF service and VRF node. And lastly, it's very easy to be integrated. We have a very complete and mature docs on our website that has been used by hundreds and thousands of developers already. The feedbacks are generally pretty good. And the implementation is rather easy and straightforward as well, as Todor may have more detailed when he goes through the process with you guys. So yes, this is Chainlink VRF in production. And from an overview of it, we have served millions of requests in these 2 years. Just in the last 30 days, we fulfilled over 2 million of randomness requests. These are coming from over 500 different unique contracts. Well, every contract is a customer or a project, so you can say that it's pretty well adopted. Chainlink VRF is in the industry is known for its security, it's known for its performance, and we have our awareness across all chains. A lot of use cases are NFTs, gamings, and also some adoptions in Ruffles and other iGaming cases. With that, I will pass my mic to Todor, so he can introduce you guys with more use cases. All right, let me stop my sharing.
Okay, let me share my screen. Just a second.
Thank you, Eddie. Yeah, the first thing that came to mind was, NFT collections and on-chain gaming like scenarios, like especially like loot tables in games and in card games, like Magic, those kind of games.
Definitely, loot boxes, NFT reviews. A lot of these use cases are with that. Yeah, Todor will cover those things.
Cool.
Yeah, absolutely. So I would say there's a few use cases that have been very widely used. The first one is NFTs, just like you guys guessed. So randomness is usually applied in NFTs during the minting process. So for example, if you have some kind of generative art collection or some other randomized type of collection where you purchase something, but you don't know what you're getting until it gets revealed. There's various different mechanisms for that. That's where you would need randomness, and it needs to be reliable and verifiable, as has been witnessed in a number of hacks with some of these NFT collections who didn't use secure randomness, like Chainlink VRF. On-chain gaming, of course, yeah, you've got a myriad of different use cases here, from all kinds of game mechanics, such as questing, just deciding the range of some effect. Like, for example, if an attack can do between 10 and 20 points of damage, there's some randomness involved in here. Of course, this is something that's not super common in Web3 gaming because of costs for the most part and scalability. So more high-level gaming actions are usually used in gaming nowadays. But I mean, with faster and cheaper blockchains such as Arbitrum, I think we can see more and more lower-level gaming actions. Then just fair distribution, I would say that covers a very, very wide range of use cases, from games of chance such as dice rolls, roulette, casino, and raffles, giveaways, oversold tickets for a concert, for example. We've seen use cases like this, such as where you have too many people who want to go to an event, but there's not enough tickets for all of them. So how do you fairly distribute that? Would it be first come, first serve, or is there a more fair way? Well, we've had some use cases where people do that utilizing reliable randomness. And lastly, governance. That's probably the least common type of use cases, but I've seen things like jury selection, or even selecting who gets to vote on some kind of decision from a wider pool of voters, which really kind of helps with saving voter attention, making sure your vote counts for more, and still ensuring this fairness in the governance process And it's just as secure as getting the whole population that can vote to vote as well in many cases, if you have a large enough statistical sample here. Then yeah, let me dive a little bit into some of these. I guess gaming is a bit obvious. Like I said, there's a lot of different gaming actions. Most of what we've seen is automated questing, like in a few of the games that have implemented Chainlink VRF. So like the outcome of a quest, the rewards from that quest are decided based on the randomness from Chainlink VRF. And of course, one of the earliest and the most popular games, Axie Infinity, I just wanted to showcase that as well. They used Chainlink VRF to basically reveal NFTs back in the day in the form of loot boxes, where a player purchases something that they don't know what it is. You can call that a loot box. And then when that is revealed, the player finds out what exactly that contains. It might be more rare or more common depending on their luck. So diving a little bit more into how this works in some scenarios at least. The NFT contract could implement certain techniques. Like in this case, for example, we have an extension to the ERC721 standard called ERC721 Psi. And this extension actually implements Chainlink VRF for the reveal feature. You're purchasing basically an NFT with some kind of placeholder metadata. And when you choose to reveal that NFT, the original one gets burnt, and then Chainlink VRF is called. And when the callback function comes in, that decides basically what exactly the person is getting. A very good example of utilizing Chainlink VRF for a bit of a higher level action is shuffling. That again has many applications. You could use basically, because Chainlink VRF, the output of that function is basically a uint to 56, a very large integer. And in order to make that into something useful, you run this through an algorithm that is in your smart contract. And that algorithm could be quite simple. For example, you could use module to select a number in a range, or you could run some sort of shuffling algorithm. Usually, what works best on EVM is a shuffling algorithm that basically goes into a loop, expands this random seed received from Chainlink VRF to modify the way the elements in the array that you want to shuffle are swapped with each other until that loop is finished. And doing this on chain is quite gas intensive, burns a lot of gas. So in some cases, depending on what you're doing with this shuffle outcome, you may want to do this off chain. So basically just utilize the output of Chainlink VRF as an audit trail. And then if the shuffling algorithm you're using is published, people can still verify that, for example, if you have a deck of cards that you want to shuffle, that is shuffled appropriately. Or if it's, let's say you're running a raffle and you want to shuffle the list of participants to select the top 5, for example, for the winners, you can still verify that everything is fair and the audit trail is there on chain for you to do that. Next, we've got a lot of use cases where you have NFTs used for blockchain gaming, where the NFT represents some kind of character or item, and it has built-in attributes. Selecting these attributes a bit randomly, for example, from a range, predefined range, that's used a lot with the output of Chainlink VRF. And it's quite simple to do this using the modulo operation. So if you get the output of VRF and then apply the modulo operation to it with the number, say 100, that will give you an output between 0 and 99, completely random, with a completely ignorable modulo bias, because the input is a very large number, like 73 digits. Yeah, and there's another example here of distribution of season rewards to players, where you could get the output of Chainlink VRF plugged into a function, and then that outputs in turn the distribution slightly randomized in order to introduce some gamification to the system. I will move on to the live demo now. If there are no questions, let me just check quickly. Any questions there we want to answer?
No, it looks clear on questions.
Okay, so now I will just show pretty much how quick and easy we can deploy and interact with a Chainlink VRF enabled contract. The only preparation I've done here is just gotten some funds for a faucet from a faucet, because faucets are a little funky sometimes. Okay, there we go, Sepolia. Not all not all testnets are easy to get funds from, so I took it from Sepolia. It's pretty much the same on Arbitrum Gorley. So this is the docs for Chainlink VRF. I'm not gonna read through all of this. You guys can do this on your own time, but I'm just gonna go through the flow quickly. So the first thing is creating a subscription that is used for the billing, how we pay for VRF. Basically, a subscription happens by calling the VRF coordinator contract, and you have a very nice UI here that makes it very easy. I'm just gonna have to confirm in MetaMask here, which I'm not sure if it's seen on my screen, but that's what I'm doing right now. And once this transaction gets mined, I'll have my subscription created. This can be done also programmatically, but the UI just makes it really easy. Okay, just check quickly. Okay, there we go. This is my subscription. I just created it. The next thing I'm gonna do is fund it with some link. Let's say Chainlink. So now, once this subscription is funded, its funds can be spent by authorized consuming contracts. I don't have a consuming contract yet. I'm going to create and deploy now, and I'm going to use just the example we have here in our docs. There we go. I'm opening it in Remix. So it's a very, I'm just going to go quickly through this contract. It's a very, very simple contract. VRF follows a request response model. So there's two main functions: request randomness and fulfill randomness. The request randomness is called when your end user calls your contract to initiate some action, and that in turn calls the VRF coordinator requesting a random number. And then the fulfill randomness is initiated by the VRF service, calls the VRF coordinator contract, which verifies the random number, and only if it is valid, if it passes the verification, only then forwards it to the consuming contract, to the fulfill randomness function. So here's the request random words function and fulfill random words function. Here in the body of the fulfill random words function, you can insert any kind of logic, whatever you want to do with the random number you've received. So if you want to roll a dice between 1 and 6, you would do something like result is equal to random words. That's an array. So for example, the first element array, if you requested one random word, mod 6 plus 1, that would give you a number between 1 and 6 based on the randomness received from VRF. Then just implementing this is super easy. We have a VRF consumer base abstract contract that implements all the functions that you need. There's a few configuration parameters, the subscription ID. This is based on the subscription that we created here. My subscription that I just created is 2177. I have not added the consumer yet. I will do after I deploy this contract. But I gotta make sure that this subscription ID is configured in my contract. Then callback gas limit. This is just the limit that this specific call to the consumer contract can consume. That's you can configure that maximum if you don't want to, for example, spend too much gas. Then request confirmations. This is the number of blocks that we can wait. The VRF service waits until it generates a response. The minimum on Arbitrum is 1. So we generate, if you set it to 1, because there's no reorgs, that's safe to do. That means that basically the end-to-end response time from the VRF service on Arbitrum is about 2 seconds. I think that's almost Web 2-like. That's quite the game changer, I would say.
Pun intended.
Yeah, exactly. And then just the coordinator address, all these details can be seen in our docs in the supported network section. It's pretty easy. This is pre-configured for Sepolia. The key hash is also basically a commitment from the VRF service to a private key that will be used to generate the random number. And that's pretty much it. So I'm just going to go ahead and compile this contract, and then I'm going to deploy it. I need to provide the subscription ID when deploying it. It is 2177 based on what I just created in the VRF UI. And oops, sorry, I need to switch to MetaMask. There you go. Deploying the contract now. Once it's deployed in Remix, it will show up here. There we go. That was pretty quick. So we now have a contract deployed at this address that I'm going to check in Sepolia in Etherscan. Just so we can check that it's there. There you go. This is the contract just created 22 seconds ago. No interactions yet. I'm going to go back to Remix to now finish everything. So now I have this contract. It's deployed. I'm going to copy its address, and I'm going to go back to the subscription UI and add it as a consumer. What this means is that this contract, once this transaction is confirmed, is now allowed to spend the balance of this subscription. And I funded it with Chainlink. Check, yeah, there we go. It's funded with Chainlink. The consumer is added. This contract can now spend the balance of this subscription. So when I make a request from this contract, the VRF service will generate a response. And then we can try this now. So there is the function request random words. It doesn't take any parameters. We're just starting this transaction. We can view it on Sepolia. It's pending. Once it's confirmed, the VRF service will respond right away, actually on Sepolia after 3 box confirmations. and we'll see the random numbers that we requested. Here is the contract. Here the request randomness function. Okay, here's the response transaction. We can see it either scan the walks that have been emitted. Oh, sorry, this is the request transaction, my bad. The response transaction. 1 second. The response transaction probably, oh, yeah, we can see it in the UI very easily. There you go, that's a recent fulfillment. Here's the transaction hash of the response. That's still being indexed by the Block Explorer. Sorry guys, Arbitrum Goerli, I couldn't get any Arbitrum AEs in time for this demo, so I'm doing it on Sepolia. It's a bit slower. But there it is, yeah, success. So going to the walks, we see the request was fulfilled, the walk was emitted, and here's the two random numbers that were generated because we requested two random numbers with this. That was another configuration parameter. And this is pretty much it. I'm gonna stop sharing and see if you guys have any questions.
I had a question actually, but you can take Carlos's first. He's asking, does Chainlink VRFs on Arbitrum have anything unique to offer? Well,
yeah, I think I actually mentioned it a little bit while I was doing this demo. The end-to-end response on Arbitrum is just insane. It really doesn't feel like a blockchain, and that's probably one of the problems with having secure randomness on a blockchain. You cannot do it in one go. There needs to be, because everything is public, everything is transparent, everything is deterministic. You need to have a commitment by the user to some action in one transaction, and then consuming the randomness in a subsequent transaction. And this happens so fast on Arbitrum that you don't even realize that you have to wait. So I think that's pretty unique.
my question was around, I guess, like how, in terms of gaming, like let's say you're in a dungeon and you defeat a boss together with your group, and then there's obviously the loot randomness. How does it like differ from Web 2 in the sense, like what do Web 2 games use compared to what the VRF is?
Right. I guess I can help to address this. So yeah, I mean, again, in a typical dungeon games in the Web 2, even like World of Warcraft, when you're getting loot, it's normally just by algorithms, in-game algorithms. So they have their algorithm of generating pseudo randomness. However, that's pretty centralized code. So it can be altered. It can actually get altered by the game developers. In Web3 space, though, when we want a more, I guess, fairly shared gaming scenarios, obviously a in-game code that could work to generate a randomness number, but that number is not tamper-proof, is not verifiable. In a lot of ways, VRF can provide. I think that's the key difference. So while they are available, but we provide a more fair and secured way of helping the end users as well. So this is real. This is fair.
All right, cool. Thanks, Eddie. Any other questions for Todor and Eddie while we have them here? If not, where can people go to, I guess, ask questions later on with like, dev support with implementing VRF?
I think Discord is probably one of the best places for more complex questions. Maybe post it on Stack Overflow and tag it to Chainlink.
And just, it's all on the main Chainlink Discord? Like,
Yeah,
they can ask about
well,
that stuff.
yeah.
Okay.
There's a VRF channel on Discord.
Okay,
VRF
perfect.
developers.
All right, cool. Well, there's no questions, which makes sense because you covered everything that I could have thought to ask about it. If you guys have anything else you want to mention, feel free to. Any hot tips to VRF using it in ways that people might not, think to do it standardly?
I think I just want to share an observation that we've reached at some point, because we built this service for to solve the problem that smart contracts don't have access to reliable randomness. But at some point we realized that this is just better randomness compared to what anyone else uses in the Web2 world as well, because it is done in a way that nobody can cheat. The provider or any of the users or anyone involved in the process. And that's not the case with any of the cryptographically secure randomness algorithms that exist in the Web2 world. Cryptographically secure means that just that they're unbiased, that the output is uniformly distributed. VRF adds a lot more to that. It makes it provable that the randomness was unpredictable to anyone, and that nobody could have tampered with it. And I think that's that's a real application of blockchain technology that is applicable to a lot of real world use cases outside of the blockchain space as well. I think that's exciting personally.
Yeah. Just want to add some context into this one. Definitely agree with Tudor, and then we're really exciting to have Chainlink VRF on Arbitrum, knowing that Arbitrum is such a I guess high performance chains to enable so many potential use cases, especially in utility, granting real utilities to Web3 services, and this is what VRF has been, I guess, designated to do as well, to help you guys. There are a lot of existing solutions in Web2, like what Toto was saying, definitely cannot fulfill Web3 use cases. Just imagine, NFT drops if people know already what's upcoming. And then think of blockchain games, if developers can alter I guess, the drop loot. A lot of these cases on Web3 scenarios just need VRF. So we're really excited to have our solutions actually working with Arbitrum now, and then we're really excited to see what everyone can build on top of that. Yeah, so thanks for the session. It's really excited.
So if a Web2 game wanted to implement this, I guess, but they don't like leverage the blockchain in any way, is there ways to do that where like you can implement a smart contract into a game that like is coded in, let's say, like C++?
You could do that, and there's some attempts to do that. I mean, I think the future of Web3 games is more hybrid. Probably not the whole game will be on chain in the future. I mean, it has to be justified by the use case. It needs to be something that that matters, where it matters to to interact with the blockchain, pay the gas fees, etc. It's but a lot matters in a lot of games, like competitive games, for example. Imagine something like a trading card game like Hearthstone with tournaments, where drawing the right card at the right time could mean
Do
you
not
win
get
the
me
tournament
started
even.
on
Yeah.
Hearthstone tournaments. I used to compete like full time a long time ago, and there were just times where you felt like, you played everything right, you did the math, you counted the cards, everything checks out, and then the randomness just feels like something wasn't right. Like it does.
Yeah. Well, if you get something like Chainlink VRF utilized under the hood to draw the cards for you, then you could also be certain that you didn't get cheated. you can
All right,
go
well,
there, check the
let's
box
get Blizzard
for.
on the line. I might still have some contacts there. So we'll
There you go. I mean, we'd appreciate the intro.
Yeah. All right. Great, guys. Thanks so much for taking some time this Monday to walk people through this. And there'll be a recording on the YouTube, as most people usually check it out later once, their time zones are more appropriate.
Thank you as well.
Thank you. Yep.
All right. Thank you, guys. Take care. Enjoy the rest of your week.
See. Bye.